Okay gang, we're back with 3.1, and again this is called finding the derivative by the limit process. So this is the derivative and this is finding it by the limit process when you take the limit of the difference quotient. So we're going to now find the derivative of this function by the limit process. Alright, here we go. Now, you first have to create f of x plus h. If you recall, that's when you take the f of x function and everywhere you have an x, you replace it with x plus h. So everywhere you have an x, you replace it with x plus h. So you actually have to create this f of x plus h function. So for us, it's going to be x plus h quantity squared minus 4. Now this is a really popular place, what I'm about to do next, to make a mistake. So please pay attention and try to remember how to do this correctly. So there's a minus in the formula, but this minus is saying subtract all, not part, not half, not just the first guy, subtract all of f. So in your mind, you've got to, or I write it out, you've got to subtract all of the original function, okay, which means that everybody in here is going to have to change sign. And this is all over h. Okay, so that's the basic setup, and now it's just doing the algebra and then doing the calculus of the limit. Now, I don't know how many steps you guys want for this, so maybe let me add a little more if you need it. Let me just squeeze it up here. Remember, this means that you have two of these, two photocopies of the same thing. So the result of this is going to end up as 3 terms, not just 2 terms. Sometimes students just square each of these, and that's wrong. Right? This is a FOIL, right? You have to have x times x times h. Keep it in alphabetical order when you do that. H times x, alphabetical order, h squared. You always want to go in alphabetical order because then you might not recognize like terms if they're formatted differently. It's hard to recognize patterns if you don't format things in the same manner. Alright, so this is, or you guys can just remember the formula from intermediate algebra, right? The formula that you guys learned, if you recall, is a plus b quantity squared is a squared plus 2ab plus b squared, right? You guys learned that in intermediate algebra. So that's what we just did here. First term squared, twice the middle, last term squared. Alright, so that's the foiling I just showed you. Now I'm going to bring down the rest of it. I'm going to distribute the negative here. I changed the signs. That's really important. Change the signs of everybody. Okay, so now I'm going to combine like terms. So this and this is the same family. This and this is the same. So I teach you a little trick here. You've done it right if you scan it real quickly and the only thing left have H's in it. That's usually true. Alright, now we're going to reduce the fraction. Please make sure you reduce correctly. You never half reduce the top with the bottom. You don't ever do that because this is a common denominator. So it can only be reduced with a common factor, not half of the top. Right? If you think of this like a ship, the bottom belongs to all the people on the top. You can't just put half the people over the bottom. What happens to these other guys? They're going to be floating off in the ocean, right? You don't want to do that. So everybody is over h. If you're going to reduce, you have to reduce something common as a common factor with a common denominator. All right, so we pull out the h. It's a common factor. And now I can reduce because it's a common with a common. Or if you do that quickie little way, you take out all the h's from everybody. All right, I'm almost there. These problems can get so long that you can actually forget at the very end to actually take the limit, to actually do the calculus. There's so much algebra in calculus that sometimes at the end we forget to do the calculus part. So at the very end, we take the limit, we let h go to 0, so you're going to get 2x plus 0, which is going to be 2x. All right, so what I'm saying here is that the derivative of this function is 2x. Now, sometimes when this happens, people get weirded out because they want it to be like a constant and it's an equation. But that's true most of the time, that it'll be an equation because most functions are fancy. And things that come out as constants are only very basic functions, like a line. Okay, so this is the derivative. Now I'm going to move. I'm just going to move this information over here. So we have f of x equals to x squared minus 4, and we have f prime of x equals to 2x. Okay, so that's the information. That's the function we started with, and we calculated the derivative. All right, now what I want to do here is I want to find the slope of at certain points on this function. So let me just back up a second and help you understand this before I do it. And if it goes out of focus, I'll fix it, okay? So don't worry, I'm paying attention to it. So to help people understand this concept, I'm first going to draw f. So do you remember what this looks like? If it's an x squared, it's a what? It's a parabola, right? What is the negative 4 doing to the parabola? It's moving the function down 4 units. So let's draw f. Let's have a picture of f, because that'll help you understand the concept. So this is a parabola that's shifted down 4 units and has an x-intercept at 2 and negative 2. And remember how you find intercepts, x-intercept, you would just let y equal to 0 and you would solve that out. Alright, so what I want to do is I want to find the slope at points on the graph. So the first point I want to find the slope at is the point -1, -3. So -1, -3 is right about, oops, sorry, I'm in the wrong spot. -1, -3 is over here. And what I want to do is I want to know the slope here. So what I'm asking you is what is the slope of this tangent line? Like, what's the instantaneous rate right here when I touch the graph? Now, just looking at this, you should be able to tell that the slope is going to end up being overall be what? Negative, right? The slope is overall going to be negative because this line is going down from left to right. Now, how do you actually find this instantaneous rate of this? How do you find the slope of this tangent line? Well, that's what the derivative gives you. The derivative is a slope generating function. I'm going to say that again. The derivative is a slope generating function. So right now, it only needs an x. So this is my x, this is my y. Later on, you're going to notice the derivative is going to need x and y. That's the more difficult ones. Right now, this just needs an x. So I know what my x is at this point. The x is a -1. So I'm going to plug it into the function, and I'm going to get a -2. So what I'm saying is that the slope of this tangent line is a -2. That's the slope. And if we wanted, we could calculate the whole point, right? If we wanted, we could actually calculate what this line is, right? If we have y equals mx plus b, and we know that y is -3, and we just calculated m is -2, and x we know is -1, we just need the b. Sorry, brain is not working correctly. You have to minus the 2 to the other side. B is 5. So you're going to get y equals -2x minus 5. Okay, so I could actually create this entire equation. It's negative 2x minus 5. But what I'm asking for right now is just what are the slopes at each of these, okay? But that's the idea. This is a slope. This is the slope of the tangent line. This is actually the tangent line. I actually found the line itself. I'm just going to ask you for the slopes, okay? So now I want you to find the slope at 0, negative 4. So let's take a look. Let's first find the point 0, negative 4. That's right here. All right, now that is at the bottom of the parabola. So if I draw a tangent line, it's going to sit on the parabola like this. Now before I even solve this, you could probably tell me what the slope of that is because that line is flat. So what do you think the slope of this should be? A horizontal line always has a slope of 0. Slope of 0, right? But let's actually calculate this. So do you remember how you calculate the slope? You use the derivative, which is the slope generating function. So I'm going to do f prime, the x value. It only needs the x value so far. So I'm going to plug in x is 0, and this is going to be 0. So it's telling me that the slope is 0, which I already knew that. And if you guys did want to draw the equation of the line, the equation of this line would be y equals to 4, right? Because it's a horizontal line at 4. So this is the equation that describes the line. This over here describes the slope of the line. All right, so try to keep the distinctions clear. All right, let me see if I can find, I'm having fun with all my colors. Do I have any more fun colors? I'm trying to find a fun color. All right, I don't know if blue is fun, but I found a blue. All right, so the next one I want to do is, oh, we already have blue, so let's